Right. Hello. How are you? Okay. So welcome to section 3.2. And today we shall be looking at numeration systems and whole number operations. Okay. So in 3.1, we looked at numeration systems and number bases. Okay. How to change from one base to the other. And here we shall be looking at the same numeration system and whole number operations. Now, addition of whole numbers. Okay, before we go into it, let me define what whole numbers are. Now, whole numbers are numbers that begin from what? 0 up to infinity. So whole numbers start from 0 to infinity. So numbers 0, 1, 2 up to infinity. And so the difference between whole numbers and counting numbers or natural numbers is that natural numbers start from 1. Is that okay? Good. So these shall be our learning objectives. Some of these I will skip. I have about 40 slides to go through with you. Now, number relationships, including comparing and ordering the meaning of addition by studying various models. So we shall look at addition and properties of addition and how to use them. Okay, addition algorithms, and here we shall look at some interesting algorithms you may not have come across before, how you can add with certain numbers, okay, and addition with numbers other than base 10 and mental addition computation. All right, so here, here basically we're going to look at addition, and the first thing we'll look at is the set model. So the set model is one way to represent addition of whole numbers. Okay, addition of whole numbers. So suppose Jane has 4 blocks in one pile and 3 in another. If you put everything together, we have 7, right? And let me espouse a little bit, and then let me let you know this particular formula. Now, this is because we had this because there was no intersection. So how does this thing works? This works such that you have A union. Okay, so let me put number of elements in A union B. So union means addition, basically. So this is equal to when I write n of A, it means number of elements in A plus number of elements in B. And then you have to take away the intersection, n of A, and this is not n, it's intersection of B. Okay, so this was the case because we had to, for Jane's example, there was no intersection, that's why we had 7. So if he had an intersection, the answer would have been different. So if you had an intersection, what it would have done, so here basically the intersection was 0 for this example. Okay, so note this formula closely. Okay, so n of A plus n of B minus n of A intersection. So this is intersection symbol. An intersection means what they have in common, right? Nice. So note that you may need it at some point. Okay. Nice. Now, definition of addition of whole numbers, let A and B be disjoint. So here the two sets are disjoint. Okay. So when the two sets are disjoint, that is when you can add the two. So for instance, if I had say set A, okay, and I had A, B, C, D. Now I had another set, which is my set notation symbol doesn't look healthy, right? So this is A and say E and F. And then I'm asked to find N of A union B. Okay. A union B, that means I need to add the two sets. And don't forget my formula should be N of A plus N of B minus the intersection. Okay. Now what is N of A? N of A is number of elements in A, right? How many are there? I have 4. And number of elements in B, I have 3. And what is the intersection? What is common to both? That's one intersection, right? So N of A intersection B is just my A. And that is 1, okay? And that is 1. So here, my result is going to be what? 6. Is that right? I just wanted you to know this. Very important, very significant. Okay, sweet. So let me get rid of these. And we can go to the next. All right. Nice. Now Kenzo has 4 feet, red ribbons, and now we look at number line representation, how you can add on a number line. How many feet of ribbon does he have altogether? Okay, and so for number line representation, if you move to the right, you are adding. If you move to the left, you are what? You are subtracting. So here we move 1, 2, 3, 4. And don't leave any space between, and then you move 1, 2, 3. So altogether you've moved 7 times. Okay, so that is 4 plus 3, and that is how you use number line to add. Since you guys are going to be teachers, you need to know how you need to know each of these methods so that you'll be able to students or kids learn pictorially. So these things are really helpful when it comes to number lines, when it comes to teaching of mathematics, okay? All right, so students need to understand the reason by any 2 directed arrows can be found by placing the endpoint of the first directed arrow at 0 and then joining it to the directed arrow for the second number with no gaps. I already mentioned that, or overlaps. So note this closely, okay? Nice. Now, less than, definition of less than for any whole number A and B. A is less than B if and only if there exists a number, a natural number K, and that is A plus K is equal to B. Okay, this is pretty, let me explain that. So if I have, it says if I have a number A and B, so I'll let my A be equal to 2 and my B be equal to 3. Now, if I say A less than B, that means that I'm saying 2 is less than what? 3, basically. Do you see that? Now, what this means is that if I say A is less than B or 2 is less than 3, that means there's a certain number that must be added to 2 to give me 3. Okay, so there's a certain number, which I don't know, K, that must be added to give me 3. Is that okay? And now that is what you can simplify that, and then you have K to be what? 2. So that is all to be 1, sorry. Okay, so I have 3 minus 2, and which is what? 1. So there's a certain number that must be added to the lesser number to give you the number you want, and that is what? 1. Okay, good. So we talk about less than or equal to means, you know these guys, right? A greater than B is the same as B less than A. Okay. Now counting on. So counting on is another method that you can use to teach addition. So here we're looking at various addition models, ways you can add numbers. The strategy of counting on is an addition strategy where addition is performed by counting on from one of the numbers. For example, 5 plus 8 can be computed by starting at 5 and counting 6 7, and 8. Okay, so the addition 7 plus 4 can be performed by starting 7, 8, 9, 10, and 11. Is that okay? And we call that counting on. Okay, and doubles. So this is doubles, and use doubles such as 3 plus 3 receive special attention. After students master doubles, doubles plus 1 and doubles plus 2 can be learned easily. Okay, for example, if a student knows 6 plus 6 to be 12, then using the associative property, okay, which we'll be looking at these properties later, they can easily do the remaining additions. Is that okay? So really 6 plus 7, you break that up and then you create a double, right? And 6 plus 6 plus 1, and that gives you 13. So these are ways you can teach kids addition, okay? That strategies for teaching addition to kids that helps them understand easily. Now, making of 10, another strategy is that making 10 and then adding any remaining, okay? One way is to use 10 frames to make a 10. So making of 10 is a very important and very easy way to add numbers. Now we look at whole number addition properties. Whole number addition properties. And the first property we want to look at is the closure property of addition of whole numbers. Now, it says that if A and B are whole numbers, then A plus B is a unique whole number. And we shall be looking at some examples of that. Now, the closure property implies that the sum of two whole numbers exists, and that sum is a unique whole number. We will look at it again with examples. So for example, 5 plus 7 is a unique whole number, 7. Now, this means the closure property means that if I add two whole numbers, I must get another whole number. Okay, now 5 is a whole number, 2 is a whole number. When I put 5 plus 2 together, it gives me 7, which is a whole number. So we say 7 is closed under the set of whole numbers. And that is the closure property. Is that okay? Now, assuming I'm adding, I do 5, let me do 2 minus 3. 2 minus 3 will give me minus 3. Minus 3 is not closed under the set of whole numbers because minus 3 is not a whole number. Is that okay? So that is what the closure property is all about. Nice. It must be closed under the set. Now, commutative property, and this is A plus B is equal to B plus A. Okay, so if I have 2 plus 1 is the same as 1 plus 2. So the order is not important, but I get the same result. So that is commutative property. Is that okay? Nice. So 3 plus 5 is the same as 5 plus 3. Now we have what we call the associative property of addition of whole numbers. And we have only introduced another letter, right? So for associative, we are dealing with 3 things. So what I would do is I would do A plus B. This is how you can easily recollect that and do another. Now, place the parentheses at different points, and you have done an associative property. Okay, and either of these will give you the same answer. Now we have what we call the identity property of whole numbers, and then there's a unique whole number 0 called additive identity, such that for any whole number a plus 0 is equal to a, and 0 plus a is also equal to a. Now we call 0 the identity property of addition. Any number you add to 0 gives you the same number. And that property is what we call the additive property, the additive identity of addition. Is that okay? Good. Now, which properties of whole numbers are illustrated in each of the following? So here we have commutative, and here we have closure of addition, and here we have commutative property. And if you look here, right here, we have two. We have commutative and we have associative property. Okay, we have two properties right there. Okay, and that's what you see right there. So you have two properties. So here, this is the first part. So the first part gives you the commutative. Okay, and the second, this side of it gives you the associative. Looking at this and that. Okay. Now, addition algorithms. We have what we call the concrete model. Okay, so these are concretes in different sets. You put them together and you have 37. And addition algorithms, expanded algorithms. Okay, so here what you're doing basically, you're adding, like we did, which I showed you place values. You add the tens, you add the ones first, followed by the tens in that order. Okay, so 3 plus 4 gives you 7. Okay, and then you have the 20 plus 20 plus 10 gives you 30, and then together that gives you 7. Okay. Now expanded algorithms with regrouping. Okay, so add ones, add tens, and that gives you that. Now addition algorithms, standard algorithm with regrouping. So here, if you add the ones, 7 plus 8 gives you 15. So you write 5 and you push 1 forward. Okay, and then 1 times 3, and so 5 plus 2, and then you add the 1 to it, and that gives you 65. Okay, that's the regular way, the standard algorithm, the regular way for adding numbers. Okay, that's the regular addition that we know. Okay, nice. And I showed you, I talked about longs, units, flats, and all that, and that is the same order you add these numbers right here. Okay, so I wouldn't spend time. And partial sums. Okay, so here I will pause here and talk about the lattice addition. So the lattice algorithm works. It looks very beautiful. So what you do here is that you write the numbers you're going to add. Okay, and then you draw this whole box beneath the numbers. Now 7 plus 8 gives you 15. So this, now when you divide this, you draw a diagonal. You have 1 there, and then you write a 5 right here. Okay, so the ones unit goes to the lower, and then the tens unit goes to the upper. Is that okay? And then you do 6 plus 7. You have 1 and 3, because which is 13. So the tens unit goes to the upper, and then the ones unit goes to the lower. You have 5 plus 6. You have 11. So 1 upper, 1 lower, and then 3 plus 5 is 8. Okay, so this is 0, tens, and 8 units. Now when you're done, you come down here, and then you write 5, and then you add this. 3 plus 1 gives you 4. 1 plus 1 gives you 2. Okay, and then 8 plus 1 gives you 9. And that is how you do the lattice addition. Okay, nice. Now we have what we call the column addition. We add the numbers in each column, writing each sum directly beneath them. And That is quite self-explanatory. And the column addition and opposite change algorithm. Okay, so go through that. And another algorithm that we'll be looking at is the scratch algorithm. Okay, the scratch algorithm. Now, this is how the scratch algorithm works. Add the numbers in the units place, starting at the top. So you start adding from the top. So you do 7 plus 5. Okay, that gives you 12. Now, anytime you make a 10, you cross out. You cross that out. You cross the number that made the 10. So we cross out 5. And because that is 12, you write 2 right there. Okay. Now we do 2 plus 9. Now because we made a 10, we are going to cross the 9 out, and then we write 1 right there. Okay. Now we are going to write 1 at the bottom. Now, how many times did you cross out these numbers? Twice. So we moved the number of times you crossed twice to this point. Now we're going to add 2 to 8, and that gives you 10. Because we made a 10, we're going to cross out. We're going to cross out, and that gives us a 0. So we do 0 plus 6. Okay, because we didn't make a 10, we will not cross the 6. So now we add 4. Okay, we made a 10, so we cross that out and we write a 0. Now, how many times did we cross these numbers? We did that twice. So we have 2, 0, 1. Okay, so I'm thinking of taking us through some examples on this sometime. Okay. Now, let me see. And base 5 addition table. Now we're going to add these numbers in base 5. Earlier we looked at base 5. Okay, and we're going to see how we can add in base 5. Okay, now, so 0 plus 0 gives us 0. 0 plus 1 gives us 1. 0 plus that. 0 plus any number gives us the same number. Okay, now you realize that here these numbers are changing. On this row, the last digit here, we did 1 plus 4, and this gave us 10. Addition of number bases works such that, so 1 plus 4 is 5, so it's 5. And what base are we working in? We are working in base 5. Now, when you get 5, you ask yourself, how many times can 5 divide 5? 5 will divide 5 one time. So it will be 1 time. Okay, 1 time, remainder what? 0. And that is why we have 10 right there. Is that okay? Now, let's go and see again. So here will give us the same thing. 2 plus 3 will be 5. You ask yourself, how many times can 5 divide that? 5 will divide that 1 time, remainder what? 0. So that's why we have 10. We write that as 10. Now 2 plus 4 is 6. How many times can 5 divide that? 5 goes into 6 1 time, remainder what? 1. So we have 11. Okay, and I'm coming to this row, the 4th row right here. The row of the 3. 3 plus 4 is what? 7. How many times can 5 divide 7? 1 time, remainder 3. Okay, that is why we write that as 13. 4, okay, sorry. 3 plus 4 is 7. Okay, and that is 1 time, remainder 2. So that is 12. Sorry. Okay, and 4 plus 4 is 8. How many times can 5 go into 8? That is 1 time, remainder what? 3. And that is why we have 13 right there. Okay, so that's how you add numbers in base 5. Okay, if you had to do in different bases, that's how you go about it, the same way. So here we've been asked to do 144 base 5 plus 34 base 5. So 4 plus 4 is what? 4 plus 4 is 8, but you're adding in base 5, okay? So you have your 8 right there. And how many times? And we know that 4 plus 4 is what? 13 in terms of base 5. So I'll write 3 right there, and I'll push the 1 up there. Is that okay? So 1 plus 4 is 5. 5 plus 3 is another 8, okay? And what do I get? So that is also another 3, and I push 1 there. So I have 2, 3, 3, base 5. So that's how you add in base 5. And these are mental mathematics estimation for whole number operations. Mental mathematics, the process of producing an answer to a computation without using computational aids, and computational estimation, the process of forming an approximate answer to a numerical problem, okay? Now we have adding from the left, okay? These are addition methods, mental mathematics, computation methods, and then breaking up and bridging. So you break the numbers up and then you bridge them later, right? So here, adding from the left makes sense, right? So you add from the left. So 20 plus that, 6 plus 5, and then you bring them together. Now breaking up and bridging, so you have 76 plus 20, okay? So you break 20 up, okay, into 20 and 5. Is that okay? So you have 76 plus 20, that is 96. And then 96 plus 5 gives you 105. And we have the trading off, okay? So add to make a multiple of 10, subtract to compensate, and then add the two numbers. And then using compatible numbers. So you create numbers that are compatible. You look at numbers that are easy to add, you put those together, and then you add the remaining numbers, and that is using compatible numbers. And making compatible numbers. So here, you make the numbers compatible, right? So you're adding 76 to 25. So you realize that you can make 75 and 25. Those are very compatible. And then finally, when you get that, you add 1 to it, and that gives you the answer. And we have what we call the front end adjustment. The front end adjustment. So you adjust from the front and you look at the place value together. That is the process. And grouping to nice numbers. So you group to nice numbers, you put them together, and the sum is about 200. Okay. And clustering, when used when group of numbers cluster around a common value. Okay, so this is basically an approximation. So 4,724 is approximately 4,700. Okay, or it's approximately 5,000, and 5,262 is also approximately 2,000. Sorry, why am I giving wrong numbers? So that's also approximately 5,000. Okay, so these numbers approximately around 5, and you do that and round these numbers. Okay, so here it talks about rounding. Okay, and you know how to round, right? If you want to round 726, that is about 7,000, and 38,000. 3,806 is about 4,000. You put them together and using a range of numbers, okay? And that is the end of this section. So basically, this session talks about the different ways you can add numbers and the various properties of addition, okay? So that's the end of this section and try to familiarize yourself with these methods, and they'll be very helpful in your classroom as you take your students through math. Thanks. I'll see you again. Thank you. And let me know if you have questions, okay? Thanks. Bye.